The forest and life itself seem to change shape as you move closer to examine them. A forest canopy converts sunlight into chemical energy that makes terrestrial life on Earth possible. This process is called photosynthesis, and it's why plants are green. Descending through the canopy, we find the odd residence of the forest floor. The ghost pipe is a plant and not a mushroom despite its appearance, but it's not green like the rest of the plants in the forest. So it probably isn't photosynthesizing. If it's not getting its energy it needs from the sun, how is it alive? Plants don't depend on photosynthesis alone for survival. Fungus grows in and around their roots. This fungus breaks down the surrounding rocks and soil and provides the nutrients to the trees in exchange for sugars the trees make from photosynthesis. The fungal strands connect the tree roots to other trees in the forest. The fungal filaments act like telephone lines that allow the trees to communicate and share nutrients. If a tree is attacked by insects, it will communicate with the surrounding trees and they'll raise their chemical defenses in response. A mother tree will send sugars to her growing offspring or help a sick tree to survive. Helping the sick or those in need may appear like altruism, but it isn't the kindness of the trees, it's the selfishness of the fungal network. Keeping the forest healthy maximizes the amount of food it can get from its symbiotic partners that have mastered the trick of turning sunlight into food. The forest is a riot of chemical communications that appears silent to those of us without the chemical receptors to sense it. It's like walking through a 1980s stock exchange floor with earplugs and a blindfold. And that brings us back to the ghost pipe. It has learned to hack this underground river of nutrients. It gets all of its sugars from photosynthesis and the nutrients from the fungal network without doing any of the work itself. It's not yet known if it gives anything back to the system or if it's purely a parasite. Complete solitude is rare in nature. Life is usually connected to other life in many ways. Sometimes obvious, like the food chain, predators eating prey. Other times, the connections can be harder to spot, and surprising when we do. High in the canopy of an oak tree, a master of camouflage eats its leaves, triggering communication through the underground network to the surrounding trees about this attack. The walking stick is among the largest insects in North America. This female is laying eggs. She drops the eggs from the top branches of this oak to the leaf litter on the forest floor. And this is the end of her parental investment. The eggs have a fatty protrusion on one end called the capulum. This bundle of nutrients is not for the baby walking stick. It's a child support payment. The capulum is irresistible to ants. When they come across walking stick eggs, they take them back to the long underground chambers of their nests. When they finish eating the capulum, the egg is deposited in a chamber the ants use for dumping trash. There, the eggs are protected from predators and the harsh elements while they incubate. When the egg hatches, the baby walking stick leaves the protection of the nest without raising the alarm of the ants. Evolution has shaped a payment system for the walking stick to buy transportation and protection for her eggs while they incubate. The ant receives payment in the form of food, and the walking stick gets help in producing the next generation. Two completely different species connected by mutual benefit. These connections remind us that we're all connected on this giant organism we call Earth.